have learned what is free run, how to perform free run. In session 12, we will learn how to perform free run in HyperMesh, how to import a geometry file, how to mesh align geometry, and how to connect 1D elements manually. First, I will show you the problem statement. So we are going to perform free run on a 1D Supra roll cage. This is the 1D roll cage. We are going to use the following inputs: a frequency range of 0 to 1000 Hz, number of mode shapes as 12. Cross section, we are going to use a circular tube with outer diameter of 25.4 mm and inner diameter of 21.4 mm. The model should not be constrained for free run. Now let's go on directly to HyperMesh. So in HyperMesh, first I am going to open up our model. So I will directly go to open up the HM file and click on open. As soon as I click on open, the HM file is opened up here. So if you want to rotate the model, you can press Ctrl and use the left click to rotate. Right click can be used to move the component, and scroll wheel can be used to zoom in and zoom out the component, all while pressing the Ctrl button. So now let us start with the process. So the first process here is to create a material. So go to material icon, give the name, give the color, type as isotropic, card image as mat1, click on create edit. Now here you can assume any material value you want. So we are going to use the default values E, new and row, and return. Next is hyperbeam. So in 1D page, go to hyperbeam. In standard section type, we will use thin walled tube and click on create. Here we will first define an outer radius of 12.7 and inner radius of 10.7. Now fit this to screen, and now we will go back to HyperMesh and return. Next step is to define the property. So go to the property icon, give a name to the property, give a color, type as 1D, card image as P beam, material as steel, and beam section as tube section. Now click on create and return. Next, we have to update the component with the property that we have created. So go to component, go to update, click on components, select the component you want to update, click on select. Now change this to no card image and toggle the property and select the property. Now click on update. Now click on return. Next step is to create the elements. So in 1D page, go to line mesh panel. First select the element configuration as bar 2. Select the property as beam. Select the lines by clicking on lines and click on displayed. So it will select all the lines that are displayed on the screen. Give an element size of 50 and click on mesh. Here I am just assuming an element size of 50. Now click on return. So as soon as you click on return, the elements are created, and again you can click on return. So if you want to see only the elements and not the line geometry, you can simply go to components, expand the components, and there are two icons here. Click on the first icon, which is for geometry, and now what you see on the graphics area is the elements. Similarly, if you want to see the geometry, enable the first icon and disable the second icon. This is only the geometry. So here I am going to enable the mesh and hide the geometry. Next, we are going to create a load collector. So go to load collector icon, give the load collector name as EIGRL, choose a color for the load collector, change the option of no card image to card image, click on card image and select EIGRL, click on create/edit. Here we will define V1 as 0, that is the initial frequency, V2 as 1000, that is the final frequency, and ND as the number of modes, which is 12. Now click on return and return. Now the last step is to create a load step. So go to analysis page, load steps panel. Here give the name of the analysis as free run. Change the type of the analysis to normal modes, and here uncheck everything and only define method structural. Click on the number in front of method structural and select the EIGRL load collector. Now click on create and return. Now you can save the file and solve the file. So I will save the file here itself. Now to solve it, go to analysis page, OptiStruct panel, and click on OptiStruct. As soon as it is done solving, click on results to open the results. So once the results are opened up, you can rotate the component a bit. Go to contour and click on apply. Now here what we want to see is the animation. So all you have to do is in the animation toolbar, click on the play animation button. Now the animation speed is too high, so if you want to reduce the speed of the animation, you can drag this icon on the left side and it will reduce the speed of the animation. Now the animation is very small, you cannot see the animation clearly, so you can scale the animation by a specified amount. So here you can go to this icon, that is deformed, and give a value to scale. So let's say I want to scale the results by 10, so a value of 10. As soon as you click on apply, now you can see the animation is also scaled by 10. So now you have to look at the animation for any discontinuity. So this is the first mode, we have requested for 12 modes. So if you want to change to the next mode shape, you can go to this drop down arrow and here you can select all the 12 mode shapes. So I will start with the first, this is the second mode shape. Similarly you can click on this arrow to go to the next mode shape, fourth, fifth mode shape, sixth, seventh. Now in seventh mode shape you can see an issue, and the issue is at this location it looks like the elements are not connected. So you can see this member is vibrating independently. It should be a T section. On the other side everything is connected, but on this side it is not connected. So we will rectify this, we will solve it again and we will come back to HyperMesh. So I am going to close this. In HyperMesh we will rectify the issue. So first let me exit from OptiStruct. First go to the area where the issue is present. So if I rotate this component like this, you should be able to clearly see where the issue lies. So at this location there is the issue. So what we are going to do at this location is, we are going to add some temporary nodes. So to add the temporary nodes, go to geometry page, temporary nodes panel, use shift button, press shift button and use left mouse click button to drag a window. Now let go of left mouse click button and every node inside that window will be selected. Now click on add. So here you can see at this location there are two nodes. So I will simply delete one of the node, any one of the two nodes here. So let's say I will delete this node here. Click on clear. Now I have all the nodes to recreate the elements. So what we are going to do next is delete the elements. So get out of this panel by clicking on return. Go to delete panel by going to this icon. Change the selector to elements Choose the elements you want to delete by left clicking on them and click on delete entity. Now click on return. Now we will recreate the elements using nodes. So go to 1D page, bars panel. First I will select the property as property, element type as C-beam, define the orientation. So in this case I am going to use, let's say, Z-axis, and now select node A and node B. So I am going to select node A and node B, something like this. Similarly, node A and node B, node A and node B. So I have created 3 elements using 4 nodes. So now I am sure that all the elements are connected to each other at this location. Now click on return. Go to geometry page, temporary nodes panel, and click on clear all. This will delete all the nodes. Now click on return. Now again save the file and solve the file and check the results as animations. So first I will save the file, that is overwrite the file. Now go to analysis page, OptiStruct panel, and click on OptiStruct. It will ask you whether you want to overwrite on the existing file. So I will click on yes. Once it is done solving, again I will click on results to open the file. Once the file is opened up, we will follow the same process. First go to contour, click on apply. Next start the animation. Reduce the speed of the animation. Go to deformed icon and increase the deformation by 10 times and click on apply. Now we can see again all the animations one by one. So this is the first mode, second, third, fourth, fifth, sixth, seventh. Earlier on the 7th mode shape we are getting the issues. Now this time we are not getting any kind of issue in 7th mode, 8th mode, 9th, 10th, 11th. So 11th mode is also correct. There is no discontinuity here. And this is the 12th mode shape. So just by looking at the vibration, you can immediately figure out the discontinuity in the model. In our case, there is no discontinuity. So now this model is entirely connected, and now I can proceed with any analysis that I want to perform. So here we are done with the problem statement. Now I am going to show you what you have to do in the homework. So I am just going to open up a sample homework and I will show you what you have to do here. So to open up any geometry or to import any geometry, you can go to File, Import, and select Geometry. This is used to import the geometry files, that is the CAD files. Now click on the open icon, select the geometry file that you want to import and click on open. Now once you click on open, you have to click on import button to start the importing process. So as soon as the import process is finished, you will see that the component is imported here, and now you can also close this tab to go back to model. Now you can perform free run on this component. So here this is just one part of your homework. There are total of 5 models. What you have to do here is, if you take a look here, this is surface. So there are lots of surfaces here. You have to convert this into 1D. So to convert this into 1D, you can simply create 1D lines out of these pipes. So how can you do this? You simply go to wireframe mode. In wireframe mode, you will see all the lines here. So if this is a pipe, there are total of 4 lines. All you have to do is create a midline at the center. So we have already seen how to create midline using geometry, lines panel. Here there is an option of midline. So go to midline, select the first line, select the second line and click on create. This will create a new line at the center. So this is the line that you have to use if you want to perform free run, or if you want to convert this geometry into 1D. You can also take a look at the component. There are lots of components here. The line is now inside this component. So once you are done with everything, you can also delete the rest of the components. So this you will have to perform for all the members. Also, the cross section of this 1D element is already present here, so you can use distance panel to measure the cross section, that is the diameter of both the outer surface and the inner surface, and use the same cross section for this 1D element that you are going to create after this. This you will have to do for all the homeworks, and once all the geometry is converted into 1D, you have to perform free run. That is the homework. So now let me show you all the other models on which you have to perform free run. So this is the first homework, perform free run on a tower. The file name is turnsolo.iges. These are the inputs you have to give. Extract the midlines from the geometry to convert it into 1D, and again measure the cross section first so that you can assign the cross section to the 1D geometry. Same thing you have to do for the second homework, that is on a radio tower. Third homework, which is a guard tower. Fourth homework, which is a bicycle frame. And finally the fifth homework, which is a 1D Supra roll cage. Now this roll cage is already a 1D model, so here you only have to assign a cross section. So assume a cross section here and perform free run. So with this we are done with session number 12. Thanks a lot for attending session number 12. In session 13 we are going to cover theory of 2D meshing.